Alkanes are the first homologous series that we will be dealing about. It is just carbon and hydrogen, therefore it is a hydrocarbon, and it is the simplest form of an organic structure. Now, oh, sorry, okay, that's me, not that. Now, so in alkanes, you have carbon-hydrogen bonds that are very, very strong, and therefore they are going to be very difficult to react. And the only way to react these pretty much is going to be through radical substitution. Now, radical substitution, we'll discuss these a little bit further in the second semester when we are going to do these reactions in a lot more detail. You have linear and branched, and these structures are going to become important in the next topic when we are going to draw the 3D configurations. 3D configurations is something that you need to figure out how to do, okay? Why is this changing?
So I think maybe on your
Yes, but I'm not changing, I'm not using my hands.
so the keyboard.
Now, so
Sorry.
try to-
This is still
I will have my tablet there, which is already broken. So, alkanes, then, 1 second, something happened here. Okay, now, you can have cyclic, bicyclic, or pericyclic. For cyclic alkanes, you just add the cyclo, okay? Cyclohexane, cyclopentane, cyclopropane. Cyclopropane would be very sterically hindered and therefore very reactive. Bicyclic, you don't need to know the names. Neither are for the polycyclic. You will need to know how to draw these for later modules, but I will not be teaching you those modules, okay? But even for those modules, you do not need to know the names. But it's always fun to know that that structure is cyclohexane with a cyclopentane in the middle. So remember, you have one, two, three, four, five. That would be a second structure. But you do not need to know the naming. You just need to know how they're going to line up in space. When I say line up in space, as I said before, and most of you loved, okay, you will need to build structures. So if you don't want to buy the balls and the bonds, use plasticine and toothpicks. I will be using plasticine and toothpicks here when I actually show you how to build them and build the 3D structure. And I will do that to show you that it's as good as the balls and bonds. I will bring both. Then the homologous series, you have a number of isomers, and you can see that the number of isomers increases exponentially the more carbon bonds you have. 1 carbon, 1 isomer, 2 carbons, 2 isomers, 3 carbons, 1 isomer. But then 4 carbons, you start having 2, 3, 5, 9, 18, so on and so forth, until you get, for example, 20 carbons is 366,000. For A level, it used to be fun when they ask you to draw all the isomers of heptane. it might be fun to ask you to draw the isomers of the cane, but then that would be your whole paper. So I will not do it. But please do know that for every different structure, you will start getting different isomers. And the isomers get some extra importance in this module because some of the isomers are more stable than others. Same as with alkenes, you used to have Markovnikov's rule, where the tertiary carbocations were more stable than primary carbocations. You have the boiling points and melting points. Densities are not that important, okay? But please note that the boiling point increases. There is no comparison here between methyl propane and butane, but you should know that linear molecules, linear structures have a higher boiling point than brand, okay? And cyclohexane would also have a much higher boiling point than hexane because of the packing. You can have substituents. Now, I would like to presume that you know this. Unfortunately, from my experience with students, especially for A level, these are not a given. If you don't know the naming, I expect an email by tonight so that I can give you a sheet to work. Anyone who sent me an email, I've replied to. If I did not reply to your email, then I did not receive it, which means send it again. But if you don't know the naming properly, and not just for alkanes, we are going to do alkanes, alkenes, alkynes, halogenoalkanes, aldehydes, ketones, I think some carboxylic acids. Please do send them so that we can fix it. This is not something that is not fixable, but it will be something that you will need to know. Because now at university, we will also be doing the common names. So we use UPEC names overall, but when you are in real life, there will be the common names that if you don't know them, you're going to see a bottle in front of you and have no idea what the bottle contains. So for the alkyl substituents, you have the same prefix. Prefix is always the number of carbons, but your suffix is -yl instead of -ane. You can have primary, secondary, or tertiary structures. Again, please note that the primary, secondary, or tertiary structures will constitute about how many alkyl groups you have on a carbon. If you have one alkyl group, it's a primary. 2 alkyl groups, it's secondary. 3 alkyl groups, then it's going to be tertiary. Now, for the UPEC rules, find the longest chain and name it. There are some instances that this might not be true. For example, if you have an alkene, the alkene must always be on the longest chain. If there's a substituent that might make the alkene shorter, then do not include that. We'll see some examples when we do alkenes. So this would be an octane. Then find the substituents. Substituents are normally going to be alkyl or halogens. I know that in some instances, okay, I know that in some instances you were given some really weird structures for A level. Please, most of the structures we'll be using in the scores are going to be containing a halogen, oxygens, carbon, and hydrogen only. So the weird structures, for training, they're fine. For exam purposes, they're not. Again, for this year, for the exam, you will have your beloved friend with you, Google. If you don't know something, please do Google it. Okay? The exam, as long as it's gonna be online, I will take it into consideration that you will have your notes and that you will have internet. And to a certain extent, you will have your friends. So the exams level will be accordingly. I'm not going to say it will be harder, but the questions will show that you might need to use the internet because you will. I'm not going to be an idiot saying that you're perfect students and therefore you won't be using your notes. Meta mechanisms, they will be minimized. If you were to do the exam under examination conditions normally, then for sure you will not pass. Okay? Yes? So, in some instances, you might have a structure like that. Okay? Now, that structure is methyl propyl or so 1, 2, 3, and you should be naming that methyl as 1-methyl propyl. If you want, you can also write it as 2-butyl. Okay? So 5-2-butyl octane. I think it's 8, right? 1, 2, 3, 4, 5. No, 10. Decane. Again, as far as I am concerned, I'm not going to give you those kind of structures. Okay? I think this is something that is beyond what you should know. Again, I do believe that there are things you should know. So understanding of chemistry, understanding of how you name the compounds, that is something you should know. But whenever you are on a job, what will you do? You will go online, you will do the structure, the name just given. Therefore, you just need to know that the name makes sense. You can have multiple of the same substituents, okay? Di or bis. If it's bis, that means you have a branched group. You are not used to bis unless you had transition method naming. Okay? Transition method, you had bis when you had something that had where you had a ligand that was a multidentate. Okay? But the reality is that bis is now going to be used when you have a substituent that is branched. Again, here, if you're going to use methyl propyl, please do number it as 1-methyl propyl. Okay? So everyone will know where the methyl group is. Yes? How do you know it's branched? Because look, you have either 1, 2, or you have 1, 2, 3. Okay? That's why it's branched. Now, the naming here, the methyl propyl, there is nothing written because if it was written on this, on the other carbon, then it would have been isopropyl, okay, which is an old name that's still being used nowadays. Common names that we use colloquially, yes?
The branching doesn't have the numbers.
You should write the number, but colloquially, we have some of the names are defined colloquially. What does it mean? That if you write, if you say, for example, isopropyl, it's always going to be this group. That's isopropyl. Okay? Pay attention. Whilst I will not mark them as completely wrong. Okay? Do pay attention because at this point, you shouldn't. Okay? At this point, you shouldn't. In fact, the systematic name here in the methyl ethyl is correct. It's a substituent. But again, pay attention, okay? Do take note of these. Isobutyl doesn't exist. Neither is sec-butyl, okay? It's 2-methyl-propyl or 1-methyl-propyl. Do take note of these, because if you get some naming and you get them wrong, then that will affect your mark. It will be more towards the assignments here. What's the name of the structure, rather than naming it in an exam. But it's something that you should keep in mind. Tertiary butyl, very important, because this is very common. Okay? I think even downstairs in the lab, you'll use tertiary butyl alcohol, for example. That is methyl propanol. Okay? It's very important, it's very common, so please do have an idea. I'm not telling you go home and study these, just have an idea about them. Same with neopentyl, okay? Neopentyl, you have a carbon that has 3 different methyl groups.
Sir, hello.
Yes, and
How can it be 1-methyl though?
so these are
As in,
substituents.
how can it be? How can you have a? Because if it's on the first carbon, mush.
One second.
All right.
So that substituent is there. Okay, that's gonna be 1-methyl ethyl. So this would be 1-methyl ethyl pentane.
I see. Okay, thank you.
Okay, sorry? You don't need to write the 3 because otherwise it will not be pentane. If you have it the group or a different carbon on this carbon, for example, that would be hexane. Then it would be 2,3-dimethyl hexane.
Sir,
Can you see it? 1 second, can you see that now it would be 1, 2, 3, 4, 5, 6. It wouldn't be a pentane anymore. Okay, now there was a question in the classroom that said, why don't you write 3 1-methyl ethyl pentane? Because if it were on another carbon, the longest chain would then be 6 carbons, not 5. Now, who asked me a question?
me.
Yes?
Why isn't that chain propyl, and instead we write it as 1-methyl ethyl?
Because that's showing where the bond is. The bond is on the second carbon. So we have an ethyl substituent, and that ethyl substituent again has a methyl group on it.
Okay, so if it was bonded to the terminal carbon, it would be propyl.
Yes.
Okay.
Okay. Now, at a level, this is covered, but maybe not that much. Okay? But the numbering system, you have to pick up the smallest number. Not just the smallest number. When you add all the numbers together, they should give you the smallest number possible. Okay? It's important to note this. So let's say you have which one should be carbon number 1? Carbon A or carbon B?
B.
It would have to be B. So it's 1, 2, 3, 3. Okay? Because there are two carbons and there are two substituents on carbon number 3. Okay? Again, important, but these you should have known from A-level. Yes?
Because I have two on each side.
You had octane,
Heptane.
heptane,
A
yes?
and 3. You wouldn't need to write 3 and 3, right?
So,
And you have a carbon.
that's
And
carbon.
you have another group on this one.
Then you would
need
have,
to write 3 and 3.
so yes, you would have to. So that would be 3, 3.
Oh, you wouldn't have to write.
You still need to write it because you have 5 carbons where they can be. Okay? In order not to write this where the carbons are, you need to have all the carbons with 1 methyl group on them or 2 methyl groups on them. Other than that, you have to write the numbers. So the numbers, you have to write them every single time. And for substituents, the numbering starts from the carbon attached to the longest chain. So it would be that carbon is carbon number 1. So that carbon should be a little bit easier to draw. Then remember alphabetical naming. Now, I remember this used to be a problem. Actually, 1 second. And that. The substituent is what's on the group. So if it's a methyl, that is the substituent. Because people are sleeping in this room. Huh? He is. He was. You might have been, I don't know. No. So it was either that, or else I have some water in my bag and put it on his head. I'm being nice today.
You should slap him, sir.
I might get in trouble because there is N in this video call. Now, so when the substituent is the methyl group, you have di, tri, tetra. You do not include that in alphabetical order. But if you have a substituent like that, where it is dimethyl ethyl, okay, the name of the substituent does include di, D. So that would be before the ethyl octane. Now, in the first tutorial sheet, I will be focusing a little bit on naming. So for the first assignment, beware, there will be some naming. Not for your exam. For the exam, all the naming you will have will be if you have 5-ethyl to 2-dimethyl octane and you add NaOH to it, what will happen? There, yes, I might not draw the structure, but normally it's much easier to draw the structure from a name rather than to name a structure. That's how I used to find it, at least. I don't know about you. So, can you name the structure, please? Take a couple of minutes. See if you can name this compound for me. If you want, you can write your guess in chat. This is right. You're bright, so you can do it. So don't just write the longest chain. Actually, find the answer, the name of that compound. It's not a nice compound, by the way. What the what is the others? I didn't know. Yeah, but this is not a review. Open up. Like a note, not word, a note. You take shame by the joy. One bro. Oh, this would be interesting. Let's see. Kristen, the full name. Tell us just the longest chain. I want the full name. The longest chain, that's the first step. But what's the full name?
Yes.
I mean, if you send it to me direct, to me only, it's better. So the others can cheat. Doesn't matter. Send it to both if you want, but
This right. This is just a bond, or is there a carbon
which one are you?
at the end, right? Over here. Does this count as a bond, or is this just like?
No, this is carbon.
Is there a carbon here?
That's a carbon. There's no carbon here.
Oh, okay, got it.
Okay. You're foreigner or Maltese?
Foreigner.
Foreigner, okay. First time here?
8 years.
No. Like,
No.
you were online or?
Online for the past 2 weeks, but I came the first time.
Okay, but first lesson. I wasn't told you. No, I'm asking because I haven't seen you. Sorry.
No, I know.
And please do tell me if I speak in Maltese.
That's you.
Yes, sometimes I just speak.
Hey.
So I am taking a look at what you're drawing or what you're writing. Okay? Most of you, I think, are very close. I think, surprisingly, N might have. Surprisingly,
Wait, why is it surprisingly?
because normally, from my experience as a student and then as a lecturer, the ones who butt into everything aren't the brightest kids.
Basically,
Class
fair
rep
enough.
after the first week, they tend to be the ones that are here for show.
I mean, yes
And
and
it's
no.
not, and it's not gonna like me after today. Yes, and
Pardon? Don't worry, you can joke with me, it's fine, Ta. I mean, partly for show, I guess. You're not too far off. But I do try my best.
no, listen, this is not an easy question. Send it to host. If I don't receive it, what's your name? Host. Don't them. Send it as an email. Sorry. What's your name? Jan Muscato. Yes, it's host. Yeah, I said it as an email. info@chemistrymalta.com. Yeah, bidħol fuq Zoom u telefon Zoom. So, in the meantime, I'm going to start the naming. Okay, chemistrymalta.com. So, longest chain, 8 carbons. Okay. So then you start looking at the substituents. So you have an iodo. I'm seeing some correct ones now. Okay, so and yours was correct.
Oh, thank you.
Iodo, you have 1 chloroethyl methyls.
So how do you know if it's one or, because I got it wrong because I did 2 chloroethyl. How do you know if it's 1 or 2?
So the one next to the carbon chain
All right.
is 1.
All right. Thank you.
No, because it's going to be either 1 chloroethyl or 2 chloroethyl. Yes, although students didn't write the number properly, taking a look at it, you do need to write that it's 1 chloro. Hmm? Mhm. Yeah. عندك الداي الداش قبل المثال. Yeah, okay, شيء عشان تجيني يدير دي قلت لي يعمل لي الدش داي ميتا يجيك. So then once you write the substituents, you see the alphabetical order. And you have bromo, it's 1, chloro, it's 2, M, it's 3, sorry. I forgot my alphabet. Yeah, Now, once you got the number of each, okay, then we can come up with the final answer. A lot of students or some students did the methyls before the iodo. Remember, the D for the methyl is not from the group name. It just shows that you have 2 methyl groups, 2 separate methyl groups. Quite a few students also only wrote 2 1s before of the dimethyl octane. Remember, it's 2,2-dimethyl because you have 2 methyl groups. And you're telling me the first methyl group is on carbon number 2, the second methyl group is also on carbon number 2. Okay? Now, any queries about this? Anyone unsure to why we named it like this? To why we named it as such?
Can I ask a stupid question?
Stupid question? No, a question, yes.
Does the B of bromo need to be capital or not?
What?
Sorry, Ash, I get about the smallest things. The B of bromo, capital or not?
Now, if it's gonna be the first letter of a sentence is capital. If it's gonna be a name in the middle of a sentence, no.
And if we're just writing it out, so like.
Because we're just writing it out on its own, it's capital. But
All right, thank you.
there's no penalization. So something like this in an exam would have 2 marks. You will have a mark each for writing each part correctly. So you have a mark for writing that it's octane, have a mark for writing the substituent groups, the numberings. So don't worry about whether B is big or small. I will not care. You will realize there are a lot of things I don't care about when it comes to organic chemistry. Mainly, I care about arrows and the electrons. Anything else is secondary. So, properties of alkanes. As we said, the more carbons you have, the higher the boiling point, the higher the density. Okay? And this is because you have more intermolecular forces. Alkanes only have induced dipoles. For those who have not mentioned the London forces, these are also called London forces. Okay? Because in some cases, some lecturers teach them as induced dipoles only, others as London forces. What you can't call these are van der Waals interactions. Because van der Waals interactions, they are not just induced dipoles, they have the permanent dipoles as well. Okay? Weak permanent dipoles are also similar and are also categorized as van der Waals interactions. And next lecture, we're going to start drawing these as 3D structures. As you can see, yes, let's do it with this. As you can see, we're gonna try and draw 3D structures on 2D media. And we're gonna have Fisher projections and Newman projections. Now, these are going to be very important for everything we're going to be doing from now on. So please, there will be definitely a test on these, on just the structures. And the test about these is because it's going to be very, very important. The one thing you should not do is say, "Ouija, these are easy." And therefore, you study them only a week before the exams. You will not get them correct. You need to work these over and over and over again. I'm currently teaching the 3rd years, and we needed to do these a little bit because of the module we're currently doing, okay? And we had to revise them. Because they hadn't done them for 2 years, all of them got them wrong. And we were you doing some simple ones, okay? Practice, the more you practice, the easier it will get. Okay? So, what? Now, and then you can rotate them accordingly. So for today's lecture, we are done. So I'm going to actually switch off the recording.